This is section 173. We're going to look at transformations of abstract functions. So we can actually transform any function. Now I know that we looked at the parent graphs, but what if I made up a function? And here's an example of a function that I made up. Well, the same way that we translated a parent function is the same exact way that we can transform this function. So let's just say, hypothetically, if I wanted to take this information and I wanted to put it in this chart. I picked my x values. I have 0, 2, 4, and 5. So 0, 2, 4, and 5. And then I put it as a point. So I have 0, 1, 2, 3, 4, 3, and 5, 5. Now if I just wanted to separate just my y value, I have my y values, which are 1, 3, 3, and 5. Now, what happens if I wanted to say I'm going to transform into a new function by taking my current function and adding a vertical shift to it? So this vertical shift, this is my k value. Now, because of that, that means that you're actually adding it to, remember f of x means y, you're adding 2 to all of your y values. So if I wanted to do that, I could take my y value, add 2 to it, y value, add 2 to it, y value, add 2 to it, y value, add 2 to it. I have these new set of points that I can then go ahead and graph. So if I look at this, I'm translating everything up 2 points, and I get this new graph. So let's look at the example. What if I wanted to find f of x minus 3? So my vertical shift, my k, is negative 3. So I'm going to shift every single value down 3 spaces. Or you just minus 3 to every single y value. So if I wanted to subtract 3 from 0, 1, 1, 2, 3. So there's the new value. Subtract 3 in the y from 2, 3. Subtract 3 in the y value from 4, 3. And then subtract 3 from 5, 5. And so there's my new graph, and then I can connect. And there's my new function. So my new points would be 0, negative 2, 2, 0, 4, 0, and 5, 2. Let's look at another one. What if I wanted to transform it f of x plus 2? So that's my horizontal shift, and that's going to move over 2 in the negative direction. Now that means we're subtracting 2 to your x value. Now I know you might be thinking, wait, no, Mr. Duval. It's the same plus 2. Remember, the formula is f of x minus h. Because there's a minus in the formula, it means we have to do the opposite. So I'm going to move every single value minus 2 spaces. So subtract 2, subtract 2, subtract 2, subtract 2 to every single x value. So that's going to become negative 2, 1. It's going to become, so it's at 2, 3. So that's going to be minus 2. So it'd be 0, 3. And then 2, 3. And then minus 2 from 5. So that's going to give us 3. And so that's going to be 3, 5. What if I wanted to find f of x minus 5 plus 3? So that means my horizontal shift is positive 5. So that means I'm going to add 5 to the x. And then my vertical shift is positive 3. So I'm going to add 3 to my y. So we're going to add 5 and add 3. Add 5, add 3, add 5, add 3, add 5, add 3. So my new point is 5, 4. And then 7, 6. and then 9, 6. And then 10, 8. So say that's 10, 10, 8. And there's your new graph. So, to close, what did we learn today? We learned how to transform abstract functions. So these aren't the parent graphs. These are just any function. And all you need to do is find the horizontal shift, and you need to find the vertical shift, and then you're just going to add and subtract it to the corresponding values. This does conclude our lesson. If you have any other questions, please leave them in the comments.